Alright, hello everyone. It's January the 10th again, but we're gonna do January 11th because I feel like it's better to do it at night. So I have better chunk of the day for actual work. Alright, so the first question is an easy one. Let's knock it out really fast. Last time is September the 8th. Alright, what do we have? Sum of root to leave binary numbers. You're given root of a binary tree where each node has a value of 0 or 1. If the path in this could be presented with a 13. For all leaves in the tree, consider the numbers represented by the path from root to the leaf, written the sum of these. Okay. So 1, 0, 0 plus 1, 0, 1, 1, 1, 0, 1, 1, okay. So what we can do is for each root, right? And we can compute the sum. Wait, can we compute the sum of this? I guess we can. Sum of this, and all I need to do is this. Whatever the sum value it is, we're gonna do left shift. I'm trying to see if there's any easier way to handle this instead of just going really through all the paths. We want a sum of all the binary numbers, right? So in this case, but this will return 0, so how do we know which level this one is at? Well, the answer is you don't know. So if we don't know, might as well is just sum, right? So we're just gonna go this to the end, and then we sum it. Yeah, okay. Let's just go this one to the end. Every time we go to the, we have a path, we just go left shift 1, right? Left shift 1 and then plus, left shift 1 and plus, right? And then when we add a leaf, we just add it, okay? That should suffice. Alright, so we have to go DFS, node, optional tree node, actually return nothing. And then we have a self.rest equals to 0. Right, with the if not node. Ooh, we also need a val. So not val. It's binary. What should we call it? Yeah, just call it val. Shall know self.rest plus equal val. Else if node, then we do DFS node dot left and val left shift 1 and then DFS node dot right. Wait, hold on. So what is val? Val is previous passing to me, right? So I should be this plus node dot val. And then we call it DFS root and then return self dot rest. Just trying to make it easier to handle. Alright, let's see. My bad. I forgot to add this. Got to add 0. Nope. Ooh. So 0 comes in node. So we got node dot left and val left shift 1 and plus node dot val. So it's just 1, right? So here, and then we'll left shift 1. Seems like we shift too much. So we have a val, right? Value is previous, so up until the previous, right? So we say the previous left shift 1, so this will left shift 1, and then plus the current value. That looks correct. And then we go node dot left. Oh, I see. I see. It is counted twice because right? So that is not right. All the leaf. So we need to yeah, this is not right. No, this is not right. Alright. Screw me. So what? We have to check. If not node dot left and not node dot right. So this is leaf. This is leaf. So this one shall equal to current value. Yeah, I'll make some changes. There's a current value. So if this, then we add the current value. Otherwise, aleph node dot left, then we go left, else node dot right, then we go right. How about this? Slight change, but make sure that we will only handle the value when we hit a leaf. Huh. That's also not right. If not left and not right, right? I already add current value, so we say self dot right. Oh, it's not aleph. Shoot. F. Okay, return all this. This one shall be right. Can't believe we could go through 3 different rounds. Oh. What was the previous solution? Oh. This one takes longer than I'd like, but the basic idea is simple DFS. one tricky part is that we cannot wait until reaching an empty node to increment, not increment, to add to self.rest, because we have to add to self.rest when we hit a leaf node. Otherwise, the same value, otherwise we will count, we'll overcount, right? We'll overcount the path binary values. This should go with 36, 80. What was the previous method? That was the previous method. Got some to leave. I see. See what you're doing there. Int. I am adding a 2. Look at this. I am adding a 2. Binary string. So, it was not, no, that was this. I would return this, right? And traverse no dot left plus no dot right. Huh? Can add those two? The left, right, plus, that will give us an integer, which is all the sum, plus all the sum. The sum is only evaluated. This is the sum, right? Left and the right, so we have these two sum coming up to here. Yeah, it makes sense. So all the sum that go, yeah. It's fine. Let's see. Yeah, I think this is the same. Exactly the same. But I see. Yeah, it's the same. Isn't this the same too? You can do Morris pre-order on this? Why? think I know Morris, yeah, but no, I'm not gonna dive into it. Too lazy. Alright, what do we have here? Number of boomerangs. We're given endpoints in the plane that are all distinct. Where points I, a boomerang is a tuple of points I, j, k, such that the distance between I and j equals the distance between I and k. Okay, points I, okay, tuple points I, j, k. This between I and j and I and k is equal to a number of boomerangs. It looks like something we've done before. Alright. Yeah, I think this one might have done before. So points 0, 0, 1, 0, and 2, 0. So 2 boomerangs. 1, 0, 0, 0, 2, 0. Oh, 1, 0, 2, 0, and 0, 0. Oh, good example. All the points are unique. Okay. Another example. 1, 1, 2, 2, 3, 3. Right? So we can pick, like if we pick 1, 1 as the anchor point, and then we need to find the rest of the points, the pairs, right? And each pair, well, we'll find all the values that 2 is the same, and then for them it's just permutation, right? It's permutation, it's not combination, it's permutation. And permutation is just, okay, let me see, permutation is just, I forgot, what's permutation? Permutation, let's say, 5 permutation 2 should be 20. That's oh, hold on. Oh, that's C, my bad. Permutation. Yeah. 100 permutation 3 should be 100 times 99 times 98. Yeah, so that's permutation. So yeah, we do permutation. But if we pick 1, 1 as the point, none of the others are equidistance. So that cannot be. So we pick 2, 2, then we have 2 for 3, 3. That's none. Alright, so the problem becomes, given a point, right, and we have 500. So given a point, how many of the rest of the point are of equal distance to it? Which, to translate another way, if we have 500, we can go all in squared to get the distance between every pair, right? All in squared to get every pair, and then for each pair, and we can go build a hash map with the distance as the key. I have all the values, right? All the values, and they are, so the distance is the same, right? So all of them, the distance is the same. So the same. And among those same distances, we can pick one of them. Hold on. We might be able to do it better. So we're trying to create all the distance, right? So if it's 0, right, and then we have all the distance 0 to 1, 0 to 2, 0 to 3, 0 to 4, and they all have distances. And what we want to know is if I choose 0, if I choose any point as the anchor point, we want to know what are the distances? So we choose 1 as the anchor point. Then we have the distance. And we have a bunch of it associated. Yeah, we can build a very complicated hash map. But the key, top level key, is the index. And within each index, we have another hash map with distance being the key, and then the values will just be that. Yeah, so when we build this, right, when we finish building it, so if I go the first one with the remaining, and that one is done. Second one with the remaining, and then we can compute. Yeah, we can try. I think this is one of the interviews for a Google interview. Yeah, I'm pretty sure it's a Google interview. Boomerang. Yeah, let's see how fast we can handle this. I don't think it will take too long, this one. Alright, so here's how we're going to do this. So first of all, we need a dictionary. Alright, so we're going to say a hash map equals, I want to use a default dict. So from collections, import default dict. So this is going to be a default dict, and it's going to be a dict, right? Default dict. Inside is going to be a, actually going to say a lambda. Inside is going to be a default dict of all you want to know is it's actually just int. Right, we don't even need to collect. I just need to know how many, right? So I'm going to say for I in range lamp points, j in range, let's say I plus 1 to lamp points, right? And then so at point 1, so x1, x2, x1, y1 shall equal to points I, right? And x2, y2 equals points j. And then what we're going to do is dist will equal to x2 minus x1 squared plus y2 minus y1 squared. And after that, we can do hash map dist. No. Hash map I. That's the first level. And the second level is dist plus equal 1. And hash map j, same dist plus equal 1. So we have a 1, right? So once we're done with this, right, once we handled all the hash map, now we're going to see is go through every hash map, go through every distance, and try to find if any one is larger than 1. All right. So what we need to do is for values in hash map and for this in hash map, whenever it's larger than 1, then we're going to handle it. I actually prefer to handle it in here. So let's just do rest equals 0, right? Because after we handle all the j's, right, that means the I, if we consider I as the anchor point, we already handle it. So what we need to do is just for count in hash map I dot values, right? Dot values. If count is larger than 1, then we're just going to say rest plus equal to sum, right? This. And then count times count minus 1. And then return rest. Alright. Let's see. This 1, 2. This one shall return 2. And last one shall return 1. Points. And the boomerang points. Oh, the last one's not right. Oh, that's not 1, it's 0. My bad. Yeah. This is O squared. Which is fine because I want to have 500. Alright, so now 4. Pretty well. So we use a hash map with the first level. Here's a hash map. The first level has point index as key, and the value is the second level hash map. In the second level, we have a distance as key and the number of points that have number of points that have such distance as values. This setup gives us the number of points that are a certain distance away from any points I. If this number is larger than 1, then any permutation of the points, right? Of the other points can be counted as boomerangs. So that's O squared. Now 4. I have 94. Yeah, pretty good. One line. Holy shit. Okay, distance mapped output. Yeah. Yeah. You don't need to have the actual distance. Is that really one line? Ooh, look at this counter. This plus this for x, y in points. Okay, x, y in points. And for this in, oh, hold on. So for this in points, yeah, for each one in points, and for this in points, and then we produce the distance. So that's the other one's distance, and we have the distance. Now we have a counter. That's essentially the counter. Yeah, that is the counter. And for n and oof, good one-liner. I mean, you give the one-liner, so yeah, that's good. Oh, this is it's fine. Yeah, this is good. Essentially, yeah, I was doing the counter. This is the counter. Yeah, this plus yeah. But anyway, yeah. Okay, so pretty good, and I'm gonna call it a day. So from now on, I'm gonna do at night, which is actually good. I think it's a good decision. Yeah. All right, I'll see you guys tomorrow. Adios.